Hello guys, welcome to another series, and today we'll be looking at scalars and vectors. Now, the first question we'll ask, which of the following is a scalar quantity? Electric potential, electric field, angular momentum, linear momentum. Now, the answer is electric potential. Electric potential is a scalar quantity. Now, you have to know that a scalar quantity is a quantity that has magnitude but no specific direction. Right? For instance, if I want to tell you the distance covered by somebody, the distance covered by, I'll just say 20 meters. All right? But if I wanted to tell you the displacement, which is a vector quantity, I would have said he covered 20 meters due north because I am giving a direction. So a scalar quantity is a quantity that has magnitude. Magnitude meaning size. For instance, I just said 20 meters. So that 20 meters is the magnitude. So electric potential is a scalar quantity. Electric field, momentum, anything momentum, whether angular or linear, is a vector quantity. Moment is a vector quantity. Weight is a vector quantity. Force is a vector quantity. Torque is a vector quantity. All this, acceleration is a vector quantity. Please take note of that. Which of the following pairs gives the vector quantities? Momentum and power, energy and impulse, mass and mechanical advantage, D, weight and moment. They said which of the following pairs gives a vector quantity? Now we know that a vector quantity is a quantity that has magnitude and a specific direction. Example, displacement. He covered 20 meters due north. All right, I'm giving a direction. So momentum is a vector quantity. Power is a scalar quantity. Energy is a scalar quantity. Anything energy, whether kinetic or potential, is a scalar quantity. All right. Impulse, of course, is a vector quantity. Mass is a scalar quantity. Mechanical advantage, all right, is a scalar quantity also. Weight, all right, is a vector quantity, and momentum is a vector quantity. So the pairs here that gives a vector quantity is weight and moment. Weight and moment are vector quantities. Now let's move to the next question. A man moves 20 meter north, then 12 meter east, and finally 15 meter south. His displacement from the starting point is now. Now, let's solve this question. Let's see how we can solve this question. Please take note of this because I'm about to rub it off so that we can solve this question. Please take note of this. All right, you can take the video back and then, or you can pause it and write it. So let's look at this question together. Now, a man moves 20 meter north. Now we know our cardinal point. This is north, this is east, this is south, and this is west. So a man moves 20 meters due north. 20 meters due north. All right, 20 meters due north in the north direction, and moves, and then 12 meter east. 12 meter east, this direction. 12 meter east. 12 meter east. Okay. 12 meter east. This is 12 meter. 12 meter east. And finally 15 meters south. 15 meters south is in this direction. 15 meters south. It should not be too long. That's 15 meters. This is 15 meters. Now, we're asked that the displacement from the starting point is now the displacement from the starting point. Now, this is where it started, then it moved south, then it moved east, then it moved south. So, if I take this out, all right, and then this place also is going to be 12 meters. If this place is 12 meters, this place is also going to be 12 meters. 12 meters, all right, and then take this. His displacement will be from where he started to where he ended, and it's simply just from here to here. This is his displacement. This will be his displacement. His displacement D. This will be his displacement. All right. So now this is 20. The whole of this is 20. This side is 15. This remaining part now, what do you think it will be? 20 minus 15. All right. This place will be 20. The whole of the year is 20. Just from here to here is 15. So this place will be what? 20 minus 15, which is 5 meters. Can you see it? Now, like I said, if this place is 12, this place is also 12. Now, for us to find this displacement, we are going to use the formula, right? That says that what? The formula that says the square root of the what? The what? That's horizontal component squared plus the vertical component squared. So the displacement is going to be equal to square root of, now your horizontal component is 12, that's 12 squared, plus your vertical component is 5, that's 5 squared. So D is going to be equal to square root of 12 squared is 12 times 12, that's 144, plus 5 squared is not 5 times 2, it's 5 times 5, that's 25. So this gives us D is equal to 1.4 plus 25 gives us square root of 169. And then D square root of 169 is 13, that's 13 meters. All right. So our answer is going to be 13 meters, option A. Now let's take a good look at some other questions. Object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the forces acting at angles of 120 degrees to each other. Now, when we have two forces acting at an angle, we use the formula R squared is equal to A squared plus B squared minus 2AB cos theta. Now, R squared is the resultant, A is the first vector, and B is the second vector. A is the magnitude of the first vector, and B is the magnitude of the second vector. R is the resultant, and theta is the angle. So he said an object is acted upon by two forces of 5 Newton and 12 Newton. So R squared, the resultant, is going to be equal to 5 squared plus 12 squared minus 2 times A is 5 times B 12 cos the angle is 120 degree. All right. Now, so R squared is going to be equal to 5 squared is 25 plus 12 squared is what? 12 times 12, that's 144 minus 2 times 5, that gives us 10. 10 times 12, that gives us 120 cos 120 degree. All right. Now, let's continue. So, we're going to have it that R squared is going to be equal to 25 plus 144 gives us what? 169. All right. Now, minus 120 times. Now, cos 120, take note, is the same thing as cos 60, which is 1 over 2 or 0.5. But let's use 1 over 2, half. All right. So 2 goes here 1, 2 here 60. All right. So we have R squared is equal to 169 minus 60. 169 minus 60. Now, R squared is going to be equal to 169 minus 60 gives us what? 109. Of course, we're not looking for R squared. We're not looking for R squared. We're looking for the resultant. So we take the square root of both sides. So we take the square root of both sides, becomes square root of this and square root of this. Square cancel square here. So R is going to be equal to, now square root of 109 is going to give us 10.4 Newton. All right. So the resultant is 10.4 Newton. All right. Now, the next question says two forces act on a body, one towards the north and the other towards the east. The magnitude and the direction of the resultant forces are, or the resultant force are. Now, I hope you've taken note of this because I have to rub this up. All right. You can pause the video or take it back and then write it. Now, let's solve this question. Oh my God, I just rubbed off the question. Oh my God, I just rubbed off the question. Okay, I have it here with me. All right. They said two forces, two forces each of 10 Newton, forces each, two forces each of 10 Newton act on a body, one towards the north, one towards the north, and the other, and the other towards the east. Then we ask that the magnitude and the direction of, all right, sorry, I mistakenly rubbed this off. But now that we have the question, now we can solve the question. So let's solve this question. Okay. Let me use here. Let's use here to solve it. Alright. Now, two forces of 10 Newton act on a body, one towards the north and the other towards the east. The magnitude and direction of the resultant force are, now, these are our cardinal points, north, east, south, and west. Alright. So two forces of 10 Newton act on a body. Let's say this is the body. Alright. This is the body on which they're acting on. Alright. So two forces act on this body. 10 Newtons, one towards the north and what? The other towards the east. Alright? The other towards the east. 10 Newtons. Alright? So this is 10 Newtons and then this is 10 Newtons. So let's say this is the body that they're acting on. This is the body that they're acting on. Alright? This is the body they're acting on. So 10 Newtons towards the north and the other towards the east. The magnitude and the direction of the resultant force. Now, the magnitude is going to be the resultant, all right, is going to be R, and then this is going to be the magnitude. That's the direction. This is the magnitude of the resultant, and then this is going to be the magnitude of the direction. Now, so we can put this like this, all right. Now, for us to find the resultant, how do we do that? The resultant will be equal to square root of the horizontal component squared plus the vertical component squared. That's going to be 10 squared plus 10 squared. So R is going to be equal to 10 squared. That gives us 10 times 10. That's 100 plus 10 squared. That gives us what? 100. Right? So this is going to be equal to square root of 10 plus 100 plus 100 gives us 200. All right? I can split this into what? I can split it into 100 times root 2 because 100 times 2 gives us 200. Now, square root of 100 gives us 10 times root 2. So this is going to be equal to 10 times root 2 is going to give us 10 root 2. All right? 10 root 2 what? Newton. All right? So our resultant is 10 root 2 Newton. Now, for us to find the direction, the magnitude of the direction, we use theta is equal to tan inverse of your y component over your x component. So theta is going to be equal to what? Tan inverse of, what's your y component? 10 over the same 10. So 10 divided by 10 is 1. So theta is equal to tan inverse of what? 1. And tan inverse of 1 will give us 45 degrees. All right? Tan inverse of 1 is going to give us 45 degrees because tan 45 is 1. So finally, our resultant is 10 root 2 Newton and our magnitude is 45 degrees. So which of these correlates with this? Now we have between this and this. This is where we're seeing 10 root 2 Newton in the options. This is 20, this is 20, this is 10 root 2 Newton. But they have different directions. Now go back to the question. Two forces of 10 Newton act on a body towards the north and the other towards the east. So our answer is simply option C. All right. 10 root 2 Newton and 45 degree east. So that will be all for this series. Make sure you like this video, subscribe, and share so that when I upload more videos, you get notified. Thank you.